Hello everyone, welcome to C3 Streamland. So in this video, we will play with the triangle a little bit more and we will see what more we can explore through our play. So let me quickly make a triangle using my segment tool. So here is my triangle A. Let me put B over here. I want it to be on the line. And then the third point I want somewhere here. So basically I'm trying to make an acute angle triangle where all the three angles of the triangle are less than 90 degrees. And this time I want to bisect the angles. That means I want to divide the angle exactly in half. How I can do it using GeoGebra tool? I can either choose any three vertex which are making the angle, or I can select two sides between which the angle lies, and as you can see I have bisected the angle over here. Let me try with the rest of the angles, and even in this case all the three angle bisectors meet at a single point. Let's put this point, let's define this point on the screen. That's my point D. Let me quickly go to algebra tool and hide these angle bisectors to make it little less cluttered. There you go. And that's my point right there. Now this is also again another third point that we have found somewhere else. So this is neither a centroid, this is not a circumcenter, but this is something else, because this point we found by bisecting the angles. Now let's see what happens in this case. What I want to do is I want to draw a perpendicular segment which is going through this point. So let me find a perpendicular line. That's perpendicular line. So I want it to go through D and I want it to be perpendicular to side BC. There you go. I want to do the same thing with AC line, which is perpendicular to side AC, but it is going through D, and side perpendicular to AB, but it also goes through D. And these 3 points that I got on the sides, I just want to define them. Let me define these 3 points. One here, and one here. But I just did it so that I can find these E, F, and G points. Let me quickly hide those perpendicular lines. There you go. Now, let's see what we can do. With tool, I need a tool of a circle. I'm going to try draw another circle. And this time, let's draw a circle through 3 points. So I want the circle to go through E, F, and H. Oh, and as you can see, this circle perfectly fits inside a triangle. That means that this particular point D, which is at the center of the circle, is basically at the exactly same distance from all the three sides. Otherwise the circle would have gone spilled a little bit outside the sides of the triangle. That didn't happen. That means D is exactly at the center of the circle, and D is also at exactly same distance from all the three sides of the triangle. So this particular circle that fits exactly inside the center, touching the sides at one point, we hypothetically say that it is intersecting the sides exactly at one point, E, F, and G on each side. This is called an in-center of a triangle. An in-center of a triangle. So in the last video, we saw what is centroid. One more video we explained how circumcenter can be achieved by putting a perpendicular bisectors for the sides, and this time when we bisected the angles we found an in-center for the triangle. Now let's see what happens if my triangle is either a right angled or acute or obtuse angle. So this is acute angled, and you can see how my in-center looks like. Now let me try to make it a right angle triangle where it's not exactly 90 degrees. That's exactly how my in center would look like. In either case, it will try to be exactly at the same distance from all three sides. And this is my obtuse angle triangle. So using this, we can use this in different situations where we will need a certain point which would be either exactly which is at the same distance from all the sides, or same distance from all the vertices, so in those cases we can actually make use of this in center and finding in center and circumcenter. So I hope you like this video, and I want to encourage you to try this on GeoGebra. It's a very easy tool to understand and to carry out simple operations. Plus, it is very interactive. So, yeah, and that's it for the in center.